Hello, science fans. Today we're exploring a metal that's everywhere, aluminum. You might be holding it right now in a soda can, or riding in a car or plane made lighter by it. Aluminum is the most abundant metal in Earth's crust, making up over 8% by weight. But you never find pure aluminum in nature. It's always locked in minerals, tightly bonded with oxygen. For thousands of years, people walked over tons of it, never knowing it was there. Unlocking aluminum took brilliant minds, electricity, and a revolution in science. Let's dive into the story of how this hidden metal became essential to our modern world. Imagine you're an ancient blacksmith, standing in the flickering glow of your forge. You've mastered the art of shaping metals, bronze, iron, maybe even a little gold or silver if you're lucky. With every clang of your hammer, you're transforming raw earth into tools, weapons, and art. The secrets of fire and metal are yours to command, and you know how to coax iron from its rocky prison using nothing but heat and carbon. But there's one metal you'll never see, no matter how skilled you are or how hot your fire burns. You can extract iron with fire and carbon, but aluminum? No luck. Even as you experiment with different ores and techniques, aluminum remains stubbornly out of reach. It's as if the earth itself is hiding something from you, keeping a secret locked away just beneath your feet. The reason is hidden in the chemistry. The bond between aluminum and oxygen in bauxite, the main aluminum ore, is one of the strongest in all of nature. Fire and carbon, the tools that set you free from the Stone Age, are powerless here. No matter how hot your furnace, no matter how clever your methods, you simply can't break that bond. Aluminum stays locked up, invisible and untouchable. That's why ancient civilizations never saw pure aluminum and why there are no ancient aluminum artifacts. Walk through any museum and you'll see relics of bronze, iron, and gold, but the display case for aluminum is empty. For thousands of years, humanity didn't even know this silvery metal existed. To separate aluminum from oxygen, you need something far more powerful than heat, electricity. Not just a spark, but a controlled, continuous flow of electrical energy, strong enough to break nature's toughest chemical bond. This was a technology that wouldn't exist for millennia, but controlled electricity wouldn't be available for centuries. The very idea of harnessing lightning, of channeling invisible forces through wires and machines, was the stuff of dreams and legends. It took the combined genius of inventors, scientists, and tinkerers across generations to finally unlock this new power. So, while the world entered the Bronze and Iron Ages, aluminum stayed hidden, locked away in the earth. Civilizations rose and fell. Empires were built and lost, all without ever glimpsing this elusive metal. The story of human progress unfolded above ground, while aluminum waited patiently below, untouched and unknown. The secret of aluminum was a vault with a code no one could crack. Until the age of modern chemistry, it was as if nature had set a challenge, daring humanity to solve one of its greatest puzzles. Only with the rise of scientific thinking, careful experimentation, and the birth of chemistry as a true science did the first clues begin to emerge. The quest to unlock it became one of science's greatest detective stories. Researchers pored over strange ores, scribbled notes in candle-lit labs, and pieced together clues from failed experiments. Each discovery brought them a little closer to the truth, but the final answer remained just out of reach. For centuries, no one even knew what they were missing. Aluminum was everywhere, in the earth, in rocks, even in the dust beneath their feet, but it was invisible, hiding in plain sight. The world moved on, unaware that a metal more abundant than iron was waiting to be discovered. When the race to isolate aluminum finally began, it would change everything, ushering in a new era of technology, industry, and possibility. The metal that once played hide-and-seek with humanity would soon become one of the most important materials of the modern world. Ancient people couldn't make pure aluminum, but they used its compounds, especially alum. Egyptians used alum to make dyes stick to fabric, making textiles brighter and more valuable. Greeks and Romans used alum to stop bleeding, an ancient version of modern styptic pencils. Persian potters mixed aluminum-rich clays into pottery, making it stronger without knowing why. For centuries, people used alum's magic without understanding its chemistry. The name alum was a clue to a hidden element. People knew what alum did, but not what it was. It would take modern chemistry to reveal the secret metal inside. By the 1700s, scientists began to suspect aluminum contained a new metal. Sir Humphrey Davy tried to extract it using electricity, naming it aluminum, but couldn't break the bond. In 1825, Hans Christian Ørsted produced a tiny, impure sample using a risky chemical method. Friedrich Wöhler improved the process, creating small amounts of pure aluminum powder in 1827. For years, aluminum existed only as a scientific curiosity, just a few specks in a lab. The challenge was making enough to actually hold. Scientists knew the metal was there, but it remained elusive. The breakthrough would require a new approach. The world was on the brink of a materials revolution. The hunt for aluminum was heating up. Soon, everything would change. In 1854, Henri de Ville improved the process, making solid aluminum for the first time. The metal's beauty and lightness amazed everyone, including Emperor Napoleon III. Napoleon dreamed of aluminum armor and funded de Ville's factory. Aluminum was so rare, it was used for royal cutlery and high-fashion jewelry, more valuable than gold. At the 1855 Paris World's Fair, crowds marveled at a pure aluminum ingot. The Washington Monument's capstone was cast from aluminum, displayed at Tiffany's as a wonder. But production was still tiny and expensive. Aluminum was a status symbol for the elite. The world needed a way to make it affordable. The stage was set for a breakthrough. In the late 19th century, aluminum was a precious metal, more valuable than gold. Its silvery sheen and lightness made it a material of dreams, but for most people, it was impossibly expensive. The world needed a breakthrough, and that breakthrough would come from two remarkable young minds, working continents apart, yet united by curiosity and determination. Charles Martin Hall in America and Paul Héroult in France, both born in 1863, independently set out on a quest to unlock aluminum secrets. Despite never meeting, their lives would become forever intertwined by their discoveries. Hall, inspired by his chemistry professor at Oberlin College, became obsessed with the challenge of making aluminum affordable. He spent countless hours in his makeshift laboratory, reading, experimenting, and dreaming of a world where aluminum was as common as iron. Meanwhile, Héroult, a natural-born tinkerer, set up his experiments in his father's tannery in Normandy. Surrounded by the smells of leather and chemicals, he tested new ideas, driven by a relentless curiosity and a hands-on approach to science. Both young inventors realized that electricity, still a new and mysterious force at the time, might hold the key to unlocking aluminum from its ore. But there was a problem. They needed a way to dissolve alumina so electricity could do its work. Water, the most obvious solvent, failed miserably. It simply couldn't withstand the high temperatures or break down the stubborn alumina. Frustration mounted as experiment after experiment fizzled out. Then, both Hall and Héroult stumbled upon cryolite, a rare mineral from Greenland. Cryolite could dissolve alumina at high temperatures, creating the perfect environment for electrolysis. This discovery was the missing piece of the puzzle. With cryolite and electricity combined, they could finally split aluminum from oxygen, isolating the pure metal for the first time in a practical, scalable way. Their workshops glowed with the light of electric arcs and the promise of a new era. In 1886, in a remarkable twist of fate, both men, working independently and unaware of each other, perfected the same revolutionary process. Their simultaneous discoveries would soon shake the foundations of industry and science. The Hall-Héroult process transformed aluminum from a rare curiosity into a metal for the masses. Factories sprang up, and the world's appetite for aluminum soared as it became essential for transportation, construction, and everyday life. Two young inventors separated by an ocean but united by vision had changed the course of history. Their story is a testament to the power of youthful ambition and the spirit of invention. The age of aluminum was about to begin, and the world would never be the same. Hall set up a lab in his family's woodshed experimenting with cryolite and alumina. On February 23, 1886, he used electricity to produce shiny buttons of pure aluminum. Success! He rushed to show his professor the breakthrough. Meanwhile, in France, Héroult achieved the same result just 2 months later. Héroult quickly patented his process in Europe. Both men, only 22, had solved the aluminum puzzle independently. Instead of rivalry, they developed mutual respect and friendship. Their simultaneous discovery became known as the Hall-Héroult process. Both became wealthy and successful, passing away in the same year. Their invention unlocked aluminum for the world. The impossible metal was finally within reach. The Hall-Héroult process was an economic earthquake. Aluminum's price dropped over 90% in just a few years. Factories sprang up near cheap hydroelectric power, producing aluminum by the ton. Once rarer than gold, aluminum became an everyday material. Cookware was one of the first industries to embrace it. Light, durable, and modern. The metal of emperors was now in every kitchen. Aluminum's transformation was complete, from curiosity to essential. The revolution predicted in Hall's classroom had come true. The age of aluminum had truly begun. When aluminum became cheap and abundant, it didn't just change a few things, it transformed the entire world around us. Suddenly, a metal once considered more precious than gold became the backbone of modern life, quietly supporting the structures and technologies we rely on every day. Its incredible strength-to-weight ratio made it the perfect material for transportation. Engineers and designers could now build vehicles that were lighter, faster, and more efficient than ever before, opening up new possibilities for travel and trade. Even the Wright brothers recognized its potential. They used aluminum in the engine of their very first airplane, making their historic flight possible and setting the stage for the future of aviation. Thanks to aluminum's unique combination of lightness and strength, aviation soared to new heights. Airplanes could fly farther, carry more passengers, and connect distant parts of the globe, shrinking our world and bringing people closer together. The automotive industry was revolutionized too. Cars became lighter, more fuel-efficient, and safer as aluminum parts replaced heavier materials. Today, nearly every car on the road relies on aluminum for its performance and safety. Architects and builders embraced aluminum for its versatility. It doesn't rust, is easy to shape, and can be used for everything from window frames and roofs to entire building facades. Our skylines are filled with gleaming structures made possible by this remarkable metal. Just look around your home. Window frames, kitchen foil, ladders, and countless other everyday items are made from aluminum. It's become so common that we often forget how extraordinary it really is. And here's another amazing fact. Aluminum is 100% recyclable. In fact, about 75% of all aluminum ever produced is still in use today, making it one of the most sustainable materials on the planet. From the soda cans we drink from, to the spacecraft exploring the farthest reaches of our solar system, aluminum shapes our high-tech world. Its versatility and durability make it essential for both everyday life and cutting-edge innovation. The hidden metal of the past has become the foundation of modern life, supporting everything from our tallest buildings to the smallest gadgets in our pockets. Thanks to the ingenuity of Hall and Héroult, aluminum now helps us build, travel, and explore in ways our ancestors could only dream of. Their discovery continues to shape our world in countless ways. So next time you see a shiny piece of aluminum, remember, you're looking at science in action, and a metal that truly built our modern world.